Hi. Okay, we're starting 2-1 relations versus functions. I want you to answer the questions down to here on your own. If you're in class, you're doing this with a group. At home, you're doing this on your own. So you don't have to think in terms of math. Just think in terms of the word relation, how it's kind of a base word for relationship. So think of some relationships. And then answer the other questions and pause the video and then come back. Okay, how can we determine if a relation is a function or not? For each y value, there is only one x value relation, then the relation is a function. And really, I think it's clear if we say for each, because this says for each y value, there's only one x value. Okay, so let's look at different y values. So let's say we have a 6 y value and a 7 y value, so these are our y's. It says they each have to have their own, but really this one could have 2 and it could have 4. So this one y value has 2 x values and this is still a function. So 6 can go with 2 and 6 can go with 4. So really this should say for each, cross it out and put x value, there's only one y value. So in other words, let's say for this x value, it also goes with 5. So you got 2 with 5, 2 with 6, 4 with 6, and let's say 5 with 7. And these are our x's, these are our y's. For each x value, there's only one y value. So right here, this 2 with this 5 and this 2 with this 6 is not a function because you're using the 2 twice. The x's cannot repeat. The x does not repeat. So for each x value, it can only have one y value. So this right here, if it was a function, this could not happen. It couldn't go 2 to 5 and then 2 to 6. It could only go 2 to 6 or 2 to 5. So I'm just crossing this out, actually, is what I'm doing. Okay, so that could not happen if it was a function. The vertical line test, on a graph, if you see a segment that is vertical, then the graph may not be a function. I believe they left out the word. There should be an N. Sorry about that. Not be a function. I think the word not is left out right there. So let's look at some different representations of relations. And let's see, are they a function or not a function? So does each x value have exactly one y value? X to one y, x to one y, yes. So yes, this is a function. But this one, each x value has one y value. This x value has just one y value. This x value has... Now the y values are the same, but it just says each x value can only have one y value. Like if I had a line going to the 3 from the 1, now it's a problem. If I had another line going from the 2, it's a problem. But this is 1, 6, 2, 6, 3, 6, 4, 6. The x's do not repeat, so yes, this is a function. Now look here. Each x value has its own y value. Well, this x value has 2 y values. No, not a function. The 1's would repeat. You'd have 1, 3, and 1, 6. The x's repeat. No, not a function. This is a table. It's not a mapping. These are mappings with the arrows and the ovals. This is a table. Now see how the x's repeat? You're like, oh, they repeat. But look, they go to the same y value, so really these two are just the same point. And so really, it's not you still only have one y value for this x value, and it's 19. So yes, this is still a function. Okay, characteristics of functions and relations. Graph these points. So go ahead and graph these points right now. Do that on your own. Okay, so look at the screen and make sure that yours looks like mine. Now notice these lines form, or these dots, I'm sorry, form a line. They're all in a row. That's a little bit wider than I wanted it to be. Let's undo that. Let's use a different line. Let's just use the green arrow line. Match the green and through the dots. Okay, so there's your line. And identify the domain. Now the domain, write in your notes, the domain are just your x values. So, and put them in order. And we're going to write them in parentheses as a list. So you have, I'm going to go from smallest to largest. You have -3, -2. See, I'm getting them right here. This, and this, and this, and this. There's your x values. And then identify the range. Your range is your y values. Well, look, the y value, -2, -2, -2, -2. We don't have to write it 4 times, just write -2. And again, in your notes for yourself, write y values. And then as a relation of function, can we draw a vertical line segment with this? That's the vertical line test. Do any of the x's repeat? No, so yes, it's a function. It's a function if the x's do not repeat. Is it continuous or discrete? Because you can make a line through all of them, it is continuous. However, they do list the points individually. It would have to be a little bit more clear on a test. I feel like, so you know, is this a line or is this just 4 discrete points? And I'm going to say because they form a line, it's continuous. Continuous means it forms a line or smooth curve. Discrete means it's just discrete points sitting all by themselves. Okay, graph the next set of points. And identify the domain. Again, that's your x values. So your x values are smallest to largest would be 0, then 2, then 4. And you don't have to list them twice. I mean, you can, but usually you don't. So 0. The only reason I would list them out is so you can see, uh-oh, I have x's repeated. I can already see that my domain shows that this is not a function because my x's repeat. And then identify the range, my range of my y values, and it's just 5, -5, 5, -5, 5, -5. So your range is 5 and -5. And it doesn't matter if these repeat or not, so I'm just going to leave it 5, -5. And really you should do smallest to largest. So I'm going to switch that like that. And then is it continuous or discrete? Now these just look like 5 discrete points. If I drew lines up and down and it was a graph given to you, this would actually be considered continuous if it was lines. But since they're just 5 discrete points, we're going to say it's discrete. It's 5 discrete points. No smooth curve, no line that we can just make. Okay, now go ahead on your own. I want you to label each axis, label the x and y axis, label each coordinate, indicate the coordinates. Are they positive or negative in each quadrant? Like, is the x positive here? Is the y positive here? Is it negative? Tell me here. And then here put, is this the x-axis or y-axis? Is this the x-axis or y-axis? And then number your quadrants right here. Okay, hopefully you paused the video and you labeled everything. If you didn't, pause the video now and do that. And hopefully you have Okay, X here and Y here. Quadrant 1, we usually use Roman numerals. 2, 3, and 4. And then, are they positive or negative? Hopefully you did that. Oops, my microphone's falling off. Okay, so this here is your X, and I'm going to use blue for positive, red for negative. So here your X's are positives, because over here X is 1, 2, 3, and these are all positive. Your Y would go up. Like if I just randomly picked a point right here, your X would be positive and your Y would be also positive. Now what if I picked a point randomly in this quadrant, like maybe right here? Now our X is negative and our Y is still going up, so our Y is still positive. And then over here, if I picked a point randomly, like here, notice we'd have to go -1, negative, whatever that is, so negative, negative. And then here, our X is in the positive direction. If I just picked a point like right here, our X is in the positive direction. But our Y is down, so we'd have to go down, so our Y is negative. And that's it for today. I believe there might be an exit ticket or something for practice of what you did today, but maybe that's coming tomorrow. Okay, that's the end.